Hello there, Mr. Sutton here, bringing you the BC Calculus 517 Part 1 homework solutions on integration by parts. On this problem, they're telling us that the integral of x squared cosine of x dx equals f of x minus some other integral, and they want to know what this magic mystery function is right here. So based on the format of this looks like an integration by parts kind of situation. We've essentially got some uv sort of function that this f of x is, and then we're subtracting some other integral. So to tackle this problem, I'm going to try integrating the original by parts, and then if I get a matching integral over here, whatever I have in this f of x spot, I'm going to call that f of x. So let me pick out my u and my dv values. For u, I'm just using my acronym LATE. Algebra comes before trig. X squared, I would rather differentiate that than integrate it. So I'm going to make x squared my u value. And then my dv value, I'm going to let that be cosine of x dx. So then du, that's going to be 2x dx. And then for v, the antiderivative of cosine of x, that's going to be sine of x. All right, following the 7 here, plugging into my formula, we've got x squared sine of x minus integral of, this is going to be 2x sine of x dx. And taking a look now, I see that I have the same integral in the original problem as I have in the work that I just did here. So that means this other stuff, the x squared sine of x, must be my f of x function. So that's going to be choice B. For this problem, I want the antiderivative of x times cosine of x. Now, there's no way to simplify or use substitution here, so I'm going to use integration by parts instead. So here's my parts formula, uv minus integral of v du. Picking out my u value, I'm going to choose x because algebra works better than trig for u values, and I'm using my acronym LATE, A before t. And then dv is going to be cosine of x dx. du then is going to be 1 dx. And v, that's the antiderivative of cosine of x, that's sine of x. Following the 7 now to plug things in, I've got x times sine of x minus the integral of sine of x times 1 dx, but I don't really need that 1 in there if I don't want it. So now, completing the problem, finishing that antiderivative, here's the original stuff, x sine of x. And now the antiderivative of sine itself, that's negative cosine. So minus minus gives me plus cosine of x, and then plus c. So that ends up being, let's see, these are all pretty similar. I choose choice B on this one. For this problem, I'm trying to take the antiderivative of x over 2 times this exponential function. There is no way to simplify or substitute here. We're going to have to do integration by parts. So I've got my parts formula, uv minus integral of v du. For my u value, I'm going to pick the function out of these two that I would rather differentiate than integrate. And between the two of these, I would much rather differentiate x over 2. If I have to integrate that, that's going to make it something with an x to the second power, which is going to make things worse inside this v du integral. So I'm going to use u as x over 2. That means dv is going to be this exponential term. So now the derivative of u is going to be 1/2 dx. Antiderivative of dv, giving me my v value, that's going to be, let's see here, e to the negative 3x over 4, and now I have to multiply by the reciprocal of this derivative inside here. So this is going to be times negative 4 over 3, e to the negative 3x over 4. So kind of a pain to take that antiderivative. You had to divide by the tail, essentially. But again, it's going to work out a lot better because I can at least take the antiderivative of this and, get something that doesn't get any worse. All right, so now putting it all together, I've got uv following the 7 here. I've got, let's see, x times 4 on top, 2 times 3 on the bottom. So that's 4x over 6 or 2x over 3, and that's going to come out negative. And then we also have that e to the negative 3x over 4 next to it. Now for the v du, I've got 4/3 times 1/2. That's going to be 2/3. So we have a negative 2/3 e to the negative 3x over 4. But we're already subtracting that integral. So I'm just going to double negative that and make it positive. So positive integral of 2/3 e to the negative 3x over 4 dx. Okay, at this point, we just have to take this antiderivative. So I'm still going to be multiplying by the reciprocal of that inner function. So this is going to be negative 4/3 times 2 over 3, which comes out to negative 8 over 9, e to the negative 3x over 4. We still have that original stuff. Now we have a negative 8 over 9, and don't forget your plus c. So that's going to come out to which answer choice? Looks like B. For this problem, I've got a table of f and its derivative, and they're telling me the integral from 0 to 4 of f is 8. Based off of that, we want to know the integral from 0 to 4 of x times f prime. Now, since I can't combine these in any way or use any kind of substitution, I don't even really know what f does algebraically, I have to use integration by parts instead. So here's my definite integral integration by parts formula. We have uv from a to b, evaluation box, and then the integral of v du. So let me pick out my u and my dv values. For u, I want to pick the thing that I would rather take the derivative of than integrate. And I'm going to go with x on this one for u because there's a few reasons. One, it's got an easy derivative. It's just 1. But also, I would rather integrate f prime because that's going to become f, which I already have values for in this table. So just thinking ahead a little bit about what dv is going to be. That's going to be f prime of x dx for dv. So now my derivative, du, that's going to be 1 dx. Antiderivative, as we just said, that's f of x. So no problems there. Let's go ahead and plug some things in now. So we've got uv, that's x times f of x, evaluated from, in this case, 0 to 4. And then we have our integral going the other way on the 7 here. So that's going to be f of x evaluated or integrated from 0 to 4. And now we've got the original stuff that was inside my evaluation box. I've got 4 plugged into all that stuff, minus 0 plugged into all that stuff. And over here, you might have wondered why I didn't bother writing out what the derivative or the antiderivative of this thing is. Well, they already told me that from 0 to 4, the f function evaluates to 8. So I'm just going to write minus 8 and be done with this piece here. So now going through each of these things, f of 4, that's negative 3. So I have 4 times negative 3. And 0 just goes away. We still have a negative 8 there. So this is negative 12 minus 8, or negative 20. Choice A. For this problem, I want the definite integral of x times e to the negative x from 0 to 1. I can't really combine or simplify these or use substitution, so I'm going to use integration by parts. Here's my definite integral parts formula. I need to pick out u and dv to start with here. So for u, I'm going to go with x because a comes before e in that little late acronym. And also just in general, I would rather take the antiderivative of e to the negative x than x. So x is going to have to be u. And dv then is going to have to be e to the negative x dx. So derivative of x here, du, that's going to be 1 dx. Antiderivative of dv, giving me my v value, that's going to be negative e to the negative x. So like I said, that I'd much rather deal with that than have to turn this x into a 1/2 x squared and deal with that. All right, so plugging things in. Inside our little evaluation box from 0 to 1, we've got negative x e to the negative x. And then we've got our integral here. That's going to be negative e to the negative x, so positive integral of e to the x from 0 to 1. And now I'm just going to go ahead and take this antiderivative to get some more stuff inside my evaluation box. So let's see here. We've got antiderivative of negative e to the negative x would be positive e to the negative x, but we're subtracting it. So I've got a negative x e to the negative x, and then I've also got a negative e to the negative x from all this integral stuff. There's like 3 negatives involved here. So I'm going to plug 1 into all those things. And from that, I'm going to subtract all this stuff with 0 plugged in. Let's evaluate this now because that doesn't match any of the answer choices. Let's simplify a little bit. So for this part, we've got negative e to the negative 1. And I'm going to leave it as e to the negative 1 because I see that in some of the answer choices. They didn't turn it into a fraction. But wait a sec, I've also got this other minus e to the negative 1. So that's actually negative 2e to the negative 1 for that first piece there. Over here, this 0 is going to zero out the first term. But over here, this is really e to the 0, which is 1. It's negative, but we're subtracting negative 1, so we're actually doing plus 1 there. So that's going to match answer choice C if you just rewrite those in a different order. And we're done with this one. For this problem, I'm trying to find the definite integral from 1 to e of this weird term here. Now, since there's no way to use substitution to simplify this at all, there's no inner function that's going to cancel any of these out when I take the derivative. And since I can't really multiply these together and simplify them otherwise, I'm going to have to use integration by parts. So here's my definite integral parts formula, uv from a to b minus the integral from a to b of v du. Let me pick out my u value and my dv value now. So if I have a choice between algebra and logs, well, LATE, my acronym, tells me that logs work out better for u values. So I'm going to go with u equaling ln of x. I usually don't like taking the antiderivative of x to the fourth or any kind of algebraic function because the exponent gets higher, but it's actually going to work out in this case because logarithms have an interesting little thing that happens when you take the derivative of them. But we'll see that in a sec. So dv then, I'm going to have to go with x to the fourth dx. And now for my du, I've got 1 over x. And for my v, the antiderivative of this, that's going to be 1/5 x to the fifth. Multiplying now to get uv, that's going to be 1/5 x to the fifth times ln of x from 1 to e. And now to get my integral, I multiply the v and the du together, so I've got a 7 essentially I'm making here. So this is going to be 1/5 x to the fourth. And this is kind of neat. This x actually cancels out completely with an algebraic. So I've got integral 1/5 x to the fourth from 1 to e. So all right, so I've got this original stuff in here, and I'm going to move some things in my evaluation box after I get my antiderivative from this integral. This bumps up to a 5. Dividing by 5, we've got 1/25 x to the fifth that's being subtracted in here. And now it's time to plug in e and 1. So I've got all this stuff with e plugged in, minus all this stuff with 1 plugged in. And unfortunately, I'm going to have to do some simplifying. If it were a free response, I could stop here. But because my answer choices don't match, we got to keep going. So we've got 1/5 e to the fifth ln of e. Well, ln of e is actually just 1. So this is 1/5 e to the fifth for that first term. And then this next term we can't really do too much with. So I'm just going to rewrite it. Over here, ln of 1 is 0. So this whole first term is getting zeroed out. And we've really just got this negative 1/25 times 1 to the fifth, which is just negative 1/25. But we're subtracting it, so it's actually positive 1 over 25. All right, so now we're going to combine these. To get a common denominator, I'm going to multiply this first fraction by 5 over 5. So then when I put all this together, I'm going to have 5 e to the fifth minus 1 e to the fifth plus 1 all over 25. This becomes 4 e to the fifth if I combine like terms. We still have a plus 1 up there. We still have a 25 down there. And this finally matches one of the answer choices, choice B.